Hey guys, welcome to my channel. About a week ago, the pump in my borehole over there broke. We pulled it out and put a new one in under 7 hours, which you can see over there. But in order to prevent similar failures in the future and increase pump life by 2 to 3 times, we're going to install a variable frequency drive on the pump. This here is an NFlixin 4 kilowatt variable frequency drive, which has a single phase 220 volt input and a 3-phase 220 volt output. We're just gonna plug in the pump between 2 of these phases. We're gonna unbox it, install it and configure it, and in the end run a few tests. Let's go! Bog of all trades. I do everything and more. The variable frequency drive comes in this box over here. It's a pretty small cardboard box, and once we open it, we see an instruction manual. Very thick, contains detailed instructions to set up every single parameter. Next, we have the variable frequency drive itself. It has a COM port, a display, several buttons, analog and digital ports, connectors for power, a fan, a large heatsink, capacitors. Now, let's open it up and see what's inside. Covered in plastic film. Let's just open up the casing and see what's in there. The casing is held by 4 Phillips screws. This here is how it looks inside. We have a large circuit board. This is the main board. These 2 wires go to a subboard below it, to which the capacitors are connected, and there are also transistors on the bottom there. The circuit board is covered with varnish, meaning it will work stable even in conditions with high humidity and a lot of dust. And we have a second board there, which is for the digital control, and it's connected to the main board using this wire harness here. Let's get on with the installation. The reason these VFDs are so versatile is that they have a variety of control ports. There are exports. They are used for direct control, like turning it on or off by a 1 or 0 signal. There are analog ports to send a potentiometer signal in order to control the speed, for example. And there are Modbus and COM port controls to send complex digital signals to change the settings, for example. We are going to integrate it into our smart home / smart farm system, which, for example, we install a router for, which you can see over there. And we're just going to use the export to turn it on and off whenever needed using our ESP32 server. We have all communications in such concrete boxes. Right now, we have here the control box for the submersible pump. And over there, we have a relay controlling it in our smart home system. What we're gonna do now is install the VFD about here. And we're gonna use it not just to prolong the pump's life, but also to regulate flow by regulating frequency. Now we're going to take this jackhammer over here and drill some holes for the VFD. Okay, so we've got everything connected. Right here we have the wire coming in from the socket, and we've installed a circuit breaker over there. And here we've got a wire going out to the pump. And we've additionally added the signal wire in order to turn the variable frequency drive on and off. Let's turn the circuit breaker on and see what happens. It is turning on and now showing 50 Hertz. Let's just run the pump as a test. Very long acceleration time. And there we go. The pump is currently consuming about 8.8 amps of power. We should be seeing water coming out of the tube at any moment now. There we go. Now we can reduce the frequency and see that the flow of water also decreases. Let's stop the pump. Now we need to set it up to run at higher frequencies than 50 Hertz because we can overspeed the pump to 61 Hertz, and we need to program it to accept this wire. And additionally, we need to set up the acceleration time and deceleration time to 5 seconds, for example. So to program, we just click Program. Now we enter a group of commands. This is the P0 group. Now we select which command we want to change. Let's start with the acceleration time and deceleration time. Those are going to be P017. Read write. And currently it's at 10 seconds. We're going to lower it to 5 seconds. And now P018, going to do the exact same thing. 5 seconds. Now we're going to set up the maximum frequency. That's P010. And we're gonna set that up to 61 Hertz. And the frequency upper limit, that's P012. And we're gonna set it up to 61 Hertz. And now the last part, we need to set up the command source, and that is going to be P002, and we're going to set it up to 1 to accept commands from our smart home system from this wire over here. Also, we need to check whether X5 that we connected to the smart home system actually represents running forward. That's going to be P404. Yep, it is currently on forward run. Great. Now we can run it again and see how it works. As you can see now, we cannot run it using the run button and need to access our system. For that, I'm just gonna go on my phone and turn it on. There we go. Now it's running at 61 Hertz, and we can decrease that a bit to, let's say, 55 Hertz. And now we just wait for the water to come. We can see it's currently consuming 10.4 amps of power. If we increase it to 61 Hertz, it uses 13.7 amps of power. And if we instead decrease it to 50 Hertz, 51 Hertz is going to consume 9.3 amps of power. And there we see the water. It's coming at a good rate. Now we can just see that if we increase it, the rate of water also increases. And if we decrease it, the rate of water decreases, just like last time. Also, what is to notice, if we decrease the frequency too low, the pump will not be able to provide the head to pump up 70 meters of water, meaning we will not see any flow here. Now, let's turn this pump off. And we can see that the variable frequency drive has successfully turned itself off. So we're finally finished with the installation. The strobe effect you could see on the screen is just an optical effect. Due to frequency mismatch between camera and screen, it does not appear so in real life. In general, I recommend getting a VFD that's about twice as powerful as your pump. If you have any questions on how to set this one up on certain parameters, put them down in the comments, I'd be happy to respond. Soon, we'll be releasing a video on digital frequency setting for this VFD using our smart home system, since we need to control flow for our reverse osmosis filtration as the pre-filters get progressively clogged. So subscribe to the channel not to miss this next update. If you're interested in how we changed the borehole pump here, you should check out this video over here. It shows two methods on how you can do that easily and efficiently. Until next time, ciao!